Hello, everyone. All right, so welcome to my talk. My talk is titled "Where the Train's At: Rolling Your Own Historical Train Arrivals Data Set with GTFS-tripify." So for my talk is going to be a little different from some of the kind of more typical talks here, in that I'm not going to be presenting kind of like a cool consumer web application. I'm actually going to be presenting a tool that is intended for you guys, people that are interested in hacking with transit data and doing stuff with transit data. I built this really nifty tool that potentially lets you do certain things you couldn't do before. So without any further ado, let's jump right into it. Um, I'm not very interesting. Um, about this project. So this is kind of interesting because this project has been it's been a side project of mine for a very long time. And it started out when a journalist at AM New York named Mark Chiosaro asked me, "Hey, do you know if it's possible to get data on train arrivals in New York City?" I was like, "I don't know. I guess I'll go figure it out." And so I looked around on different data sets and different data assets that are available, and I was like, no one's really done this with GTFS with this data format called GTFS-RT, but it seems like it's possible to use it to get like historical train arrival times. I'm sure I can hack it together in a couple of weeks. 3 years later, it turns out to be really, really hard, and also kind of table flipping at times and frustrating. So this has kind of been a project that I've like worked on and off. Like every 4 to 6 months, I'll just be like, yeah, I feel like working with transit data for a little while, and I'll spend a few days like deep in the throes of MTA data, and I'll be like, no, this is awful, and flip the table and like leave. But it's gotten to the point where it's presentable, and this is kind of like basically my beta release of this project. So you guys get a preview before anyone else does. All right, so to talk about GTFS-tripify, we have to start by talking about GTFS. Now, I think a lot of you folks here are familiar with GTFS. You are familiar with it. You may love it. You may hate it. You may feel all three of those feelings in equal proportion to one another. But GTFS, for those of you that don't know, is this format for allowing transit providers to specify in a static way information about their transit system. So, let's say I'm on the MTA, I can provide to the public this GTFS feed or this GTFS record, which says, what stations are in the MTA system, what lines are in the MTA system, where are the routes located. Critically, what is the schedule of stops that all the different trains in the system are supposed to make? So GTFS is great, and it was very influential, largely because it standardized data that transit providers used to provide in like 20, 30, 40 different formats. Every single transit provider had a different format. GTFS came along, standardized it, and because of that, we now have all these great tools for working with GTFS and doing stuff with GTFS, because you can build a tool that works in one place and then all of a sudden it works everywhere. And it's great, it's awesome, it's phenomenal, even if the format itself is kind of clunky at times. Now, GTFS is actually not the be-all, end-all of transit data. GTFS does not do everything for you. It's got one really big drawback, which is that it's completely scheduled data. When you interact with the GTFS feed, you get kind of the static object, which says that, oh, here's what trains the MTA plans to run at what times over the next, 6 months. And now, if you've ever taken a train in New York City, you know that the correspondence between what the MTA plans to do and what the MTA actually does is loose at best in different universes at worst. So GTFS by itself is not good enough for important applications like the transit clocks, the countdown clocks. I think we're all super familiar with, because like if you put schedule data on those, it would just never be right. For this, they use actually a different format and a different specification called. The transit clocks don't actually use it, but it's the same feed of data. A format called GTFS-RT. That stands for GTFS-real time, and it's a format and a specification for providing real-time updates about the status of the MTA, of the status of a transit system over time. So let's kind of jump into how this works. Short answer, I have no idea. The MTA, I don't know how they do what they do, but based on what they output, it's some kind of weird Frankenstein monster. But I have some intuition about roughly how it works. So basically, the MTA has a half dozen to a dozen different dispatching systems that they run internally, right? These are the systems that the train operators and that the train planners and schedulers use to actually route the trains on the system. And there's a lot of different systems because the MTA is an old system. It's a combination of different systems, different parts of the system have been built over different times. It's very complicated. What they do is they have a few different servers kind of somewhere in the MTA, which basically take all the messages and scrape all the updates from these different dispatching centers. And then they basically keep up to date with them. And then every 30 seconds, they'll take all the information they have about like the chunk of the subway system that they're basically responsible for, and they'll use it to kind of crunch together a snapshot of like where are the trains and what stops are they scheduled to make in the future, when. They will take that information, they will build it in this format called GTFS real time, compress it using this binary protocol called protobuf, and then paste that basically to a web link, which then you or I or any other consumer application, like your Google Maps or your Trans application, can go to that web link, kind of download that file, and then uncompress that file and look inside of it to get like, oh, the next 7 train at this station is supposed to arrive in 5 minutes. And that's roughly how GTFS RT works. Here's a list of GTFS RT feeds for New York City. As you can see, there's 9 different feeds. This is actually pretty atypical. Most transit providers are, because they're a lot smaller than the MTA, only provide 1 feed. In the MTA case, there's 9 different feeds. It's a little crazy to work with, but whatever. If you're familiar with kind of the layout of the MTA system and its capital construction project history, some of the groupings of these lines may be familiar to you, like all the old IRT numbered lines are all on 1 feed. The 6th Avenue lines, the BDFM, are all on 1 feed. The G and the L are the G and the L and the 7 are special because they all had their own like different signals, capital improvement projects, different times. It's all very interesting. Now the limitation with how most applications these days use this data is that they will use it kind of in a throwaway manner. If I'm Google Maps, I only care about the most recent GTFS RT snapshot. I only care about the most recent information I have about this data subway system. I don't care about like trains that ran 2 days ago. I only care about the trains that are running right now and where they are. So if I'm like a Google Transit or Transit app, I basically subscribe to the stream of updates. Each time I get a new one, I throw the old one out. But if instead of doing that, what if we archive those old messages? What if we archive those old messages and then we look at the differences between them? Is there like kind of something interesting we can learn by doing that? It turns out yes. So here is kind of like my micro example. Imagine there's a B train which is making only these 3 stops. Is that a Q train? And imagine there's a B train which is only making these 3 stops. It stops at Atlantic Avenue, then it's supposed to stop at Atlantic Avenue, then it's supposed to stop at DeKalb Avenue, then it's supposed to stop at Canal Street. And this is an update that you got at 6 p.m. Right? So you take this, download it, save it. Right? You wait a minute, and a minute later, you download another update, you parse it, and you look at what you see, and you see that, oh, hey, now there's a B train which is on its way to DeKalb Avenue, and after it gets to DeKalb Avenue, it'll stop at Canal Street. Well, what do you know? We actually know something that's very, very interesting. By looking at the difference between the information you got at 6 p.m. and the information you got at 6:01 p.m., now you've learned something pretty cool. You've learned that this B train actually made a stop at Atlantic Avenue, somewhere in that interval between these 2 timestamps. You learn that this train actually stopped at Atlantic Avenue sometime between 6 p.m. and 6:01 p.m. Now, if you solve word puzzles like this thousands of times over thousands of time updates, what you can do is you can actually reconstruct a history, a real-time history of the actual train arrival times, right? So you download all this snapshot data, then you like crunch the numbers, and you build a table that looks something like this that tells you that like, hey, in this case, this is I think this is a 7 train, and you follow this train, you're like, okay, it stopped at 34th Street between this timestamp and this timestamp, and then it stopped at Times Square, 42nd Street between this timestamp and this timestamp, et cetera, et cetera, et cetera. And this is hugely useful because without this data, you're kind of constrained to what the MTA publishes. You're constrained to your GTFS data, which is all scheduled data, right? No real, very loose connection to reality. If you are able to kind of run this parsing operation, all of a sudden you're able to reconstruct the actual arrival history, which is like so much better than just having the scheduled data. You have like the actual arrival data. Like that is so useful and opens up whole new avenues of things that you can do with this data. So that was kind of the dream. The dream was we have all these GTFS real-time messages. Let's archive them and let's build the historical train arrival data sets with them, and it's going to be great. We're going to do all sorts of great stuff and build all sorts of great applications. Reality. This is really hard to do. If you ever want to work with data that is really hard to work with, try working with MTA data. It is terrific. Every form of, not only is it incredibly complicated, but every form of data error that you could possibly come up with, this data stream has. There's cases where you'll just get a 404. There's cases where you will, it'll pretend that it's giving you the latest data, but actually it'll give you old data. There's cases where the feed will freeze and give you the same data for a long period of time. There's cases where you'll get corrupt or partial feed information. There's cases where there will be a schema corruption, where something will not match the records and the IDs and whatnot will be like empty string or something. There's just kind of a descending list of like things that you have to defend against, which makes actually performing this process super hard. If you are super curious about that process, I wrote a very long blog post about it almost 2 years ago, or now, Jesus, that you can, the slides will be shared afterwards, I'm sure, and then you can check those slides in order to check that webpage to kind of learn more about that process. But the gist of it is, the TLDR is that, hey, you know, great thing about software is you solve a problem once and then no one else has to solve that problem again. So I built this Python package and command line client called GTFS-tripify. And this is an implementation of something that I worked on, you know, again, over a very long time, which does this for you. You take a list of GTFS real-time updates as input, and you output these really nice tables containing your actual arrival data for all the trains that were included in the slice of time that you're running it over. So how am I on time? Okay, so I'm gonna do a very fast demo, or try to, because actually, holding a microphone and, okay, that's not gonna work. All right, so basically the way it works is if you go to the MTA data archive, you can download one of these zip files. If you open it up, this is not very big, unfortunately. I'm not sure if I can make it much bigger. Okay. Forget it. Never mind. Anyway, you open up this folder and you can grab, you know, a month's worth of 7 data, right? So I went ahead, 7 train data. I went ahead and I did that. And then, you know, I went ahead, grabbed all the 7 train data for July, dropped that into a folder, and then I can run this really short little snippet of Python code. Sorry, short little command line command. If you can't see it, it's just GTFS_tripify space logify, the pointer to the folder containing all of your data, and then basically the name of the file you want to output the data to. And you run this, it processes for a bit. It takes a long time because this is thousands of messages repeated over thousands of inputs repeated over thousands of messages. And eventually you get this really nice table, which tells you that, you know, here's a complete record of every stop that a 7 train made on, I think it was July 1st, 2019, something like that. So, you know, that's pretty cool. So this is a tool that is, you know, it's publicly available. It's up on GitHub. You can go to, it's up on GitHub. It's up on GitHub, and you can go to Resident Mario-GTFS, Resident Mario/GTFS-tripify. And, you know, there's documentation and whatnot kind of showing you how it works and what it does. To kind of like showcase you the power of what you can get with actual real-time data, I'm going to show you my favorite like little toy application that I built with this over here, right? So this is, I think it's called a Minard chart. Actually, the name of it escapes me right now. But if you're familiar with Edward Tufte and kind of the visualization, data visualization, kind of his work in data visualization, a chart much like this one is on the cover of one of his most kind of influential books. Anyway, this is a chart which is every southbound 7 train trip on July 1st, 2019, from the first stop, which is in Flushing Main Street, to the last stop, which is 34th Street, 11th Avenue. Or every southbound trip from 34th Street, 11th Avenue to Flushing Main Street. It goes the other way. And you can kind of see like this really interesting kind of pattern to what's going on. This happens to be a day when the 7 trains are running quite well, actually. So there's not that much delay going on. Most of these lines are kind of very straight. I'm going to zoom in here so it's a little easier to see. So most of these lines are kind of straight, but you can still kind of see some interesting effects in the data. For example, there's a train up there which seemed to get stuck at a station and kind of bumped into the train ahead of it. You can see this kind of interesting thing the MTA does where they dispatch like 6 different trains at the same time, which is kind of a pain in the ass to work with, but they do that. And you can kind of basically see like the difference by looking at this chart. You can kind of see the difference between even on a really well-run day, on a very clean day of train trips for the MTA, you can see that there's definitely kind of a difference between like really like great service and what's scheduled to happen and what actually happens. You can see cases where the trains, get a little screwed up. Now, if this happened to be a day where there was really bad problems, like a signal train, stuck train, sick passenger, whatever, on the 7 train, you'd see it would show up, right? Like you'd see like a really big effect. And I think that's really cool. I think that having access to this kind of data really unlocks a whole new space of things that you can do with transit data. So kind of in closing, this is a thing that a tool that I built that like I said is kind of targeted at you guys. If you have an interesting transit application that you're thinking of building or that you've built or that you are excited about building, and you're thinking about using kind of schedule data in order to do it, consider using the GTFS-tripify, kind of building a real-time arrival data set and using that to do your work. Other kinds of applications, some of the things that I'm personally most excited about doing with this project are I'd love to build some public train arrival data sets. I think that people could really go crazy with that. Really showcase some really interesting stats about how the MTA works. Subway service metrics dashboards, the MTA has them. They are completely uninterpretable because we have no idea what's going on with them. You could kind of replicate those and build like better metrics or more useful metrics, and also showcase how you're doing it in a way which is kind of more palatable to the audience. And your application here, whatever you think this is kind of interesting, whatever you think you can kind of build with this, I'd be super interested in like talking to you and hearing some thoughts on some potential applications. So that's GTFS-tripify. I hope some of you will find it useful in the near future. Thank you.
Let's do 3 questions.
Okay, Q&A.
Yes.
Great. Shall I repeat the questions on the microphone?
Yes, please.
Okay.
Yeah. I can start with a question. If we go back to the chart, what are the gaps? So those gaps signify, are they the same line, and what's happening there?
Oh, I see. Okay.
Yeah.
So the question is, what are the gaps? What are the gaps between the lines in this chart signify? So I can explain the chart a little bit more concretely. So each line in this chart is a single train, right? So it's basically a sequence of stops along the 7 train route. And each line is 1 train trip over the course of that day. So cases where the line looks very smooth, that means that the train proceeded very smoothly between all of the stations it was scheduled to stop at that day. In cases where there's kind of shifts or breaks in the line, those are cases where there was a delay and the train got stuck in a station longer than it was supposed to be there. Now, a interesting artifact of this is you can see sometimes there's just complete discontinuities in the train line. That is unfortunately happens because of the way the MTA codes their data. They will sometimes, if a train is running late, they will sometimes drop the schedule data for that train completely and insert a completely new schedule with a completely new trip ID. So there's no way of, like, there are ways of logically associating like the old trip ID with the new trip ID, but it's not 100%, it's not foolproof. As a result, you'll get some kind of artifacts with like trips that seem to end abruptly in the data set. It's unfortunate, but there's only so much you can do.
Cool.
Hope that answers your question. Okay, question is, does this work with other transit agencies? The answer is maybe. I hope so, but this is still a very beta project, and I kind of started out with working on MTA data, which I figured was kind of what was most interesting to me, and also I figured like this is the most complicated transit agency, so if I can solve the problem here, I can probably build something that solves the problem for everywhere. I have not tried to apply it to anything that isn't the MTA subway system, but I hopefully it will work in other contexts as well. If you do try it, let me know, because I'm super interested in knowing whether or not it is actually applicable. And if it's not, I really want to get it to a state where it is. Sure. In this plot, no. In this plot, all the stations are equally spaced. I could have, it would have been more work. Like this was like kind of like a short demo. I wasn't kind of like interested in like measuring the distance between stations or whatnot for like this plot. I just wanted to kind of make something that like worked real fast. So I didn't do interstation distance as part of the axis. But if you're going to improve this plot and build like kind of something consumer facing based on this idea, absolutely, that's like one of the first things that you should do is you should do the spacing on the stations by distance instead of just kind of, instead of a uniform spacing. That's a great question. Yeah, that's a great question. So the question is, what do you do for lines where there are spurs, where the train can end up on different tracks depending on like the service or the time of day or whatever? So the answer is that if you run, when you run the processing job, you will get, as your output, you'll get a table, and that table will contain that table is completely unaware of routes. It will just contain the IDs of the stop the train stopped at. So if you have trains that are running, like let's say at 7 p.m. the train swapped to a different spur, what you'll see is like all the trips before 7 will be kind of going, the last stops that they're following will be on one of the spurs, and all the stops after that will appear on the other spur. It's up to you kind of as a consumer of this data to figure out how to kind of work with that and like maybe display it or use it usefully. It's a great question though.
I think there was one more question. Yeah.
Yep. Great question. So question is, in the places where the lines cross, which you can see, I think one case of that in this close-up, is that a data error or is that trains actually passing one another? So the answer is neither. It's an artifact of how I encoded these lines. If you recall, we're measuring when arrivals happen by looking at the time between the times within the sequence of snapshots, the time in the sequence of messages, right? So we have a maximum time and we have a minimum time. If a minimum time the train could have arrived at a station, and a maximum time the train could have arrived at a station. And those gaps will differ depending on like how long it took at the station, whether like the data feed went out for like a minute or whatever. And so for here, I just took an average between the maximum and minimum time. But sometimes the average will be kind of like, here to like a large number, so end up skewed above where it's supposed to be. It's an unfortunate artifact of the way I constructed this chart. But that's just kind of, like I said, this was a kind of a quick hack just to demonstrate the potential of what you can do with this data. If you actually put a lot of effort into it, you could do a lot better.
All right. That's all the questions we've got. I mean, you're going to stick around. You can talk to Aleksey.
If you have any more, if you have any more questions that you want to ask me, you can hit me up on Twitter at ResidentMario, nice. Or just talk to me afterwards.